Alright, the four factors that affect the speed of reaction is the concentration, pressure, particle size, and temperature. Let's go through one by one. Okay, if you were to increase this concentration, it will lead to an increase in the speed. The reason being that when there are more reactant particles per unit volume, as you know, concentration is mole per dm cube, right? Okay, so when there are more reactant particles per unit volume, there would be more collisions, and when there is more collisions, the tendency to have more effective collision will increase. Okay, just a recap. Effective collision means that they will hit, they will collide uh, at an energy that is more than the activation energy. Okay, so looking at the diagram, it looks like that. When you have higher concentration, you can see that there are more particles over the same unit volume. Okay, now when we talk about the particle size, okay, when there is a decrease in particle size, it would have an increase in the speed. This is because a smaller particle size will have a bigger surface area. So the more surface area will allow the reactants to collide more, and thus the frequency of effective collision will increase. Okay, so it looks something like this. And then if you have gaseous reactants, only for gaseous reactants, and you increase the pressure, it will increase the speed of the reaction. This is because when the gases are closer together in a higher pressure environment, the gas particles are closer together, so that it will lead to a more effective collision. Alright, it looks something like this, the diagram. And then lastly, of course, when the temperature increases, the particles would have more energy, they would be moving around more, and they will hit each other more with higher energy, so the frequency of effective collision will also increase.
Alright guys, this is probably my take 10 because I keep forgetting to mention certain things. So hopefully this time around will be the last time. Okay, so the reaction we're going to talk about is zinc and hydrochloric acid, which will give zinc chloride and hydrogen gas. 3 points. Okay, 3 points that you need to take note. Firstly, zinc and hydrochloric acid both are not gaseous reactants. So therefore, the pressure factor does not have any effect, so that's why it's blank there at the table. That's first point. The second point is we are going to measure the amount of gas produced for the speed of reaction. If you remember in my previous video, I said that in order to measure the speed of a certain reaction, we can use the volume of gas produced or the mass remaining. So in this case, let's say we're going to look at the volume of gas that is being produced. Second point. Third point, the third point is, for this reaction, let's assume hydrochloric acid is the excess, is in excess, zinc is the limiting reagent. Okay, it will be stated in the question whether zinc or hydrochloric is in excess. Most of the time, the acid is in excess. All right. Okay, let's get down to business. Let's say when we want to make a comparison, we want to see how factors will affect the speed, right? We will change one of the factor, the other factors remain constant. So the first factor that we're going to change is, let's say we're going to use a more concentrated hydrochloric acid. Of course, when we talk about concentration, we talk about the aqueous solution. It's not possible we talk about the zinc, right? Zinc, you probably can change the particle size or the mass, but not the concentration. There's no such thing. So let's say we increase the concentration of the hydrochloric acid from 1 mole to 2 moles in the second experiment. The kind of graph that you would see for the second experiment, so it will look like that. It will be steeper. The second experiment will be steeper because you use a more concentrated acid. But the volume of gas produced is the same. Because the limiting reagent, which is the zinc you use, the amount is the same. That's why the volume of gas is the same. Okay, right. So let's say that's if you change the concentration of the hydrochloric acid from 1 to 2. Let's say you want to change not the concentration this time around. Let's say you change the particle size. I hope I can find the blue. Okay, so let's say the next experiment you want to find the effect of particle size. So second experiment from granulated zinc. Instead of granulated, use powder form, the powder zinc, smaller in particle size. So you would expect the diagram to look like that as well. It doesn't have to be exactly the same steepness as the concentration one, but it's steeper than experiment one. That's all what I'm trying to say. Okay, and then let's say so next instead of using, let's change the temperature now, the factor of temperature. Let's say for the next experiment you actually use a higher temperature. The reverse happens if you use a lower temperature. Okay, let's say you use a higher temperature. This is room temperature, maybe 30 degrees Celsius, and then experiment 2 use a higher degree temperature. You would expect the temperature to go faster. I mean, that's what happened in the lab when you see maybe zinc and the acid is not reacting. You don't see any bubbles. What you do is just start your Bunsen burner, you flame it up, and then put your test tube there, hoping that maybe you will see bubbles and reactions to happen, isn't it? So when you increase the temperature, you will expect the reaction to go faster, and same thing, you would have a steeper slope and end off at an earlier timing, but the volume of gas produced is still the same.